What if everything in the universe, from the tiniest particle to the largest galaxy, is connected in ways we're only beginning to understand? Picture this: the stars above you, the ground beneath your feet, even the thoughts in your mind, all woven into a vast cosmic tapestry. These aren't just poetic musings, they're ideas grounded in some of the most mind-bending theories science has to offer. In this video, we're diving into 30 astonishing theories that reveal the hidden connections shaping our universe. From the eerie phenomenon of quantum entanglement to the possibility of living in a holographic reality, each theory opens a door to a cosmos far stranger and more interconnected than we ever imagined. Get ready to explore the invisible threads that bind everything together, and by the end, you might just see the universe and your place in it in a whole new light. Stay with us, because what you're about to discover will challenge everything you thought you knew about reality. Now, shifting our focus to the first of these mind-bending theories, let's explore the holographic principle. Imagine if everything you see around you, your surroundings, the stars, even yourself, wasn't quite as solid as it seems. What if it was all a kind of projection, like a hologram? This isn't science fiction. The holographic principle suggests that the entire universe might function like a hologram, where all the information about what's happening in a given space is actually encoded on its outer boundary, like a cosmic screen. This idea first emerged from the study of black holes, where physicists discovered that the information about objects falling into them seemed to be preserved on their event horizons, the point of no return. From there, the theory expanded, proposing that this could be true for the entire cosmos. At its core, the holographic principle challenges our understanding of reality itself. If everything we perceive is just a projection of information stored elsewhere, what does that mean for the nature of space, time, and even consciousness? It's a concept that blurs the line between science and philosophy, inviting us to rethink the very fabric of existence. Stay with us as we move forward to uncover even more theories that will reshape how you see the universe. Now, turning to the multiverse hypothesis, let's dive into the idea that our universe might not be the only one out there. Imagine a vast cosmic quilt where each patch represents an entirely separate universe with its own set of physical laws. Some of these universes might have stars and planets like ours, while others could be so different that they defy our understanding of reality. This theory isn't just speculative, it's grounded in scientific concepts like cosmic inflation, which suggests that the rapid expansion of the early universe could have created bubbles of space-time, each developing into its own distinct universe. The implications of this are profound. If the multiverse hypothesis is true, it could explain why our universe seems so finely tuned for life. Perhaps there are countless other universes where the conditions are entirely hostile to it. Philosophically, it challenges our sense of uniqueness and raises questions about the nature of existence itself. Are we just one of infinite possibilities? As we continue to explore this theory, we'll uncover how it ties into other ideas about the cosmos and what it means for our place in the grand scheme of things. Now, shifting our focus to a theory that reimagines the very fabric of reality, let's explore string theory. This groundbreaking idea suggests that the fundamental building blocks of the universe are not particles, as we've long believed, but incredibly tiny, vibrating strings. Imagine these strings as the cosmic equivalent of guitar strings, each vibration producing a different note that corresponds to a particle or force in the universe. This theory aims to unify all the forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces into a single, elegant framework. It's like attempting to write one universal equation that describes everything from the tiniest quark to the vastest galaxy. However, string theory faces significant challenges. For one, these strings are so small that they're currently impossible to observe directly, making it difficult to test the theory experimentally. Additionally, string theory requires the existence of extra dimensions beyond the three we experience, which adds another layer of complexity. Despite these hurdles, it remains one of the most promising candidates for a theory of everything, offering a potential bridge between the realms of quantum mechanics and general relativity. As we delve deeper, we'll see how string theory connects to other cosmic mysteries and what it might mean for our understanding of the universe's hidden connections. Now turning to a phenomenon that defies our everyday understanding of distance and connection, let's explore quantum entanglement. This mind-bending concept occurs when two or more particles become so deeply linked that the state of one instantly affects the state of the other, no matter how far apart they are. Imagine two coins flipped simultaneously on opposite sides of the universe. If one lands on heads, the other must land on tails instantaneously. This bizarre connection, famously dubbed spooky action at a distance by Albert Einstein, suggests that the universe operates in ways far beyond our classical intuition. Quantum entanglement challenges the very notion of space and time, hinting at a hidden layer of reality where everything is deeply interconnected. Scientists are already exploring its potential for revolutionizing communication, such as creating unbreakable encryption methods or even developing quantum computers that could process information at unimaginable speeds. But beyond its practical applications, entanglement raises profound questions about the nature of reality itself. Does it imply that the universe is fundamentally non-local, with everything connected in ways we can't yet comprehend? Or does it point to a deeper, underlying structure that binds all things together? As we continue to unravel this cosmic puzzle, entanglement reminds us that the universe's hidden connections might be far stranger and more beautiful than we ever imagined. Now shifting our gaze to the delicate balance that shapes the cosmos, let's explore the butterfly effect in cosmology. This concept suggests that even the tiniest changes in the early universe could have led to dramatically different outcomes across the vast expanse of space and time. Picture a single ripple in a pond, a seemingly insignificant event that grows and spreads, influencing everything in its path. In the cosmic context, this idea takes on a profound scale. Imagine a slight variation in the density of matter during the universe's infancy. Such a minute shift could have altered the formation of galaxies, stars, and even the very structure of the universe as we know it. This interconnectedness underscores the fragility of existence, revealing how delicate the balance of cosmic events truly is. The butterfly effect reminds us that the universe is a web of cause and consequence, where every action, no matter how small, can reverberate across eternity. It raises fascinating questions about the nature of our reality. Could the universe as we observe it be just one of countless possible outcomes, shaped by infinitesimal changes at the dawn of time? As we ponder this idea, we're left to marvel at the intricate dance of forces that crafted the cosmos, and how even the smallest threads in this tapestry hold the power to reshape the grand design. Now turning to the enigmatic forces that govern the very fabric of the universe, let's delve into the mysteries of dark matter and dark energy. Together, these invisible components make up an astonishing 95% of the cosmos, yet their true nature remains one of the greatest puzzles in modern science. Dark matter, a ghostly substance that doesn't emit, absorb, or reflect light, reveals its presence through its gravitational effects. It's the unseen architect shaping galaxies, holding them together as they spin through the void. Without dark matter, the universe as we know it would simply fall apart. But the story doesn't end there. Dark energy, an even more elusive force, is driving the universe's accelerated expansion. Imagine the cosmos as a balloon being inflated faster and faster. Dark energy is the mysterious hand behind this relentless stretch. What's truly fascinating is how these two forces are intertwined in the cosmic dance. Dark matter's gravitational pull helps form the large-scale structures of the universe, while dark energy dictates its ultimate fate. Will the universe continue to expand forever, growing colder and more distant? Or will dark energy eventually reverse its role, leading to a dramatic collapse? These questions not only challenge our understanding of physics, but also force us to rethink the very nature of existence. As we explore the hidden connections between dark matter, dark energy, and the cosmos, we're reminded that the universe is far more complex and far more mysterious than we could ever imagine. Now, stepping into the grand architecture of the cosmos, let's explore the cosmic web, the intricate network that binds the universe together. Picture this: galaxies aren't scattered randomly in space, but are instead strung along vast filaments of gas and dark matter, like beads on an invisible thread. These filaments stretch across billions of light years, connecting massive galaxy clusters and leaving vast, empty voids in between. This structure, shaped over billions of years by the gravitational pull of dark matter, is the backbone of the universe. It's not just a static scaffold, it's a dynamic, ever-evolving system. The cosmic web tells the story of how the universe grew from the faint ripples of the Big Bang into the complex tapestry we see today. As galaxies and clusters form along these filaments, they funnel gas and energy, fueling star formation and shaping the destiny of cosmic structures. The voids, on the other hand, are more than just empty spaces. They're the result of the tug of war between gravity and the universe's expansion. Together, the filaments and voids create a delicate balance, a cosmic dance that continues to shape the universe as we know it. What's truly remarkable is how the cosmic web connects everything from the tiniest particles to the largest structures in a single, unified framework. It's a reminder that the universe, for all its complexity, is deeply interconnected, a web of hidden links that binds us all. Shifting our gaze to one of the most thought-provoking ideas in cosmology, let's explore the anthropic principle. This principle suggests that the universe's fundamental constants and laws are precisely fine-tuned to allow the existence of life. Think about it. If gravity were slightly stronger, stars would burn out too quickly. If the electromagnetic force were weaker, atoms wouldn't hold together. These delicate balances seem almost too perfect to be coincidental. The anthropic principle doesn't just highlight these fine-tuned conditions, it asks why they exist in the first place. One interpretation is that we're living in a universe tailored for life because, well, we're here to observe it. If the conditions weren't just right, life as we know it couldn't exist, and we wouldn't be here to ask the question. This idea leads to fascinating implications. Some scientists propose that our universe might be just one of many in a vast multiverse, each with its own set of physical laws. In this scenario, it's not so surprising that at least one universe would have the right conditions for life ours. The anthropic principle also raises philosophical questions about the nature of reality. Are we here by chance, or is there something deeper at play? Does the universe have a purpose, or is it simply a product of random possibilities? Whether you see it as a scientific observation or a cosmic mystery, the anthropic principle reminds us that life's existence is tied to the very fabric of the universe, inviting us to ponder our place in the grand scheme of things. Now turning to a theory that blurs the line between science and science fiction, let's dive into the simulation hypothesis. This mind-bending idea suggests that our universe and everything in it might be an incredibly advanced computer simulation. Imagine a civilization so technologically advanced that they could create a virtual reality indistinguishable from the real world. The roots of this theory can be traced back to philosophers like René Descartes, who questioned the nature of reality, and more recently to futurists like Nick Bostrom, who formalized the argument in modern terms. Bostrom's trilemma poses a fascinating question. Either advanced civilizations never reach the technological capacity to create such simulations, or they choose not to, or it's statistically likely that we're living in one. The philosophical implications are staggering. If we're in a simulation, then everything we perceive, our bodies, the stars, even time itself, could be lines of code in a vast program. This raises questions about free will, consciousness, and the meaning of existence. Are we merely characters in someone else's game, or is this simulation a tool for learning, exploration, or even entertainment? Scientists are even exploring ways to test this hypothesis. Some suggest looking for glitches in the fabric of reality, tiny inconsistencies or patterns that could hint at underlying code. Others propose examining the limits of physics to see if there's a resolution to the universe, much like pixels on a screen. While the simulation hypothesis remains speculative, it challenges us to rethink what we consider real and pushes the boundaries of both science and philosophy. Whether you find it plausible or far-fetched, it's a theory that forces us to confront the mysteries of existence in a whole new way. Now shifting our focus to one of the most perplexing questions in cosmology, let's explore the Fermi paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everyone?" This paradox highlights the contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars and planets. Statistically, it seems almost certain that life should exist elsewhere. Yet, despite decades of searching, we've found no signs of intelligent civilizations. So, why the silence? One possibility is that life is incredibly rare. Perhaps the conditions needed for life to emerge and evolve are so specific that Earth is one of the very few, if not the only, planets where it has happened. Another theory suggests that intelligent civilizations might self-destruct before they can develop the technology to communicate across the stars. Climate change, nuclear war, or other catastrophic events could wipe out advanced societies at a critical stage. Alternatively, it's possible that intelligent life exists but is so far beyond our understanding that we can't recognize it. They might communicate in ways we can't detect or operate on timescales that are incomprehensible to us. Some even speculate that advanced civilizations might deliberately avoid contact with less advanced species, choosing to observe rather than interfere. The Fermi paradox forces us to confront profound questions about our place in the cosmos. Are we truly alone, or is the universe teeming with life that remains just out of reach? As we continue searching for answers, this paradox reminds us that the universe is full of mysteries waiting to be unraveled. Now turning to a cosmic phenomenon that challenges our understanding of the universe's origins, let's explore the Big Bounce theory. This intriguing idea suggests that the universe doesn't have a single beginning or end, but instead undergoes endless cycles of expansion and contraction. Imagine the universe as a giant cosmic spring, expanding outward until it reaches a limit, then collapsing back in on itself, only to expand again in a never-ending loop. This theory offers an alternative to the traditional Big Bang model, proposing that what we call the Big Bang might not have been the true beginning but simply one of many bounces in an eternal cycle. One of the most fascinating aspects of the Big Bounce is how it connects to the concept of a multiverse. If the universe continually cycles between expansion and contraction, it's possible that each bounce could give rise to a new universe with slightly different physical laws. This means that our universe might be just one in an infinite series, each with its own unique properties and potential for life. The Big Bounce also raises questions about the nature of time and space. Could time itself restart with each cycle, and if so, what happens to the information from the previous universe? While the Big Bounce remains a theoretical concept, it's supported by certain interpretations of quantum mechanics and cosmology. Some scientists believe that quantum effects could prevent the universe from collapsing into a singularity, allowing it to bounce back instead. However, this idea is still hotly debated and much remains to be discovered. The Big Bounce challenges us to rethink not only the origins of our universe but also the very nature of existence. Could the cosmos be a never-ending dance of creation and destruction? Or is this just one chapter in a far grander cosmic story? As we continue to explore these questions, the Big Bounce reminds us that the universe is far more dynamic and mysterious than we ever imagined. Now shifting our gaze to another cosmic puzzle, let's delve into the ekpyrotic universe theory. This fascinating idea suggests that our universe was born from a collision between two higher dimensional brains. Imagine these brains as vast, flat surfaces existing in a higher dimensional space. When they collide, the energy released from the impact could have sparked the creation of everything we see today. This theory offers a fresh perspective on the Big Bang, proposing that it wasn't a singular event but rather the result of a dramatic cosmic encounter. One of the most intriguing aspects of the ekpyrotic universe is how it redefines our understanding of time. If the universe emerged from a brain collision, it's possible that time as we know it began at that moment. This raises questions about what existed before the collision and whether time could have flowed differently in the higher dimensional space. The theory also suggests that our universe might be just one of many, with other brain collisions giving rise to entirely separate universes, each with its own unique properties. The ekpyrotic universe theory is closely tied to string theory, which posits that the fundamental building blocks of reality are tiny, vibrating strings. These strings exist on brains, and their interactions could explain the forces and particles in our universe. While this idea is still theoretical, it provides a compelling framework for understanding the origins of the cosmos. It challenges us to think beyond the traditional Big Bang model and consider the possibility that our universe is just one piece of a much larger, multidimensional puzzle. As we continue to explore the mysteries of the universe, the ekpyrotic universe theory invites us to ponder the nature of reality itself. Could our universe be the result of a cosmic collision in a realm beyond our perception? And if so, what other secrets might lie hidden in the higher dimensions? This theory reminds us that the cosmos is full of wonders waiting to be uncovered, pushing the boundaries of our imagination and understanding. Now turning our attention to an equally captivating concept, let's explore the zero-point energy field. This idea revolves around the notion that even in a complete vacuum where it seems like nothing exists, there is still a fundamental energy present. This energy, known as zero-point energy, is the lowest possible energy state of a quantum system, and it's constantly fluctuating even in empty space. At the heart of this theory lies quantum mechanics, which tells us that particles at the subatomic level are never truly at rest. Instead, they exhibit tiny, random fluctuations in energy. These fluctuations give rise to the zero-point energy field, a background hum of energy that permeates the entire universe. It's as if the cosmos itself is alive with an invisible, ever-present force, one that defies our everyday understanding of emptiness. What makes this concept so intriguing is its potential applications. Some scientists speculate that zero-point energy could be harnessed as a virtually limitless source of power. Imagine tapping into this cosmic energy field to fuel our technologies or even spacecraft. While this remains speculative, the idea challenges us to rethink what's possible and pushes the boundaries of our technological capabilities. Moreover, the zero-point energy field has profound implications for our understanding of the universe. It suggests that what we perceive as empty space is anything but empty. Instead, it's teeming with energy and activity at the quantum level. This ties directly to other theories such as quantum entanglement and the nature of space-time, hinting at a deeper, interconnected fabric of reality. As we ponder the zero-point energy field, we're reminded of the universe's boundless mysteries. Could this invisible energy hold the key to unlocking new frontiers in science and technology? And what does its existence tell us about the true nature of space, time, and reality itself? This theory invites us to look beyond the visible and explore the hidden forces that shape our cosmos. Now stepping into one of the most perplexing puzzles in modern physics, let's examine the black hole information paradox. This theory centers on a fundamental clash between two pillars of science, quantum mechanics and general relativity. At its core, the paradox arises from the question of what happens to information when it falls into a black hole. According to quantum mechanics, information can never be truly destroyed. Every particle, every interaction leaves a trace that should, in theory, be recoverable. But general relativity tells a different story. It predicts that once matter crosses a black hole's event horizon, it's lost forever, crushed into a singularity where the very fabric of space-time breaks down. So, which one is right? Does information vanish into the abyss of a black hole, or is it somehow preserved? Physicists have been grappling with this dilemma for decades, and it strikes at the heart of our understanding of the universe. One proposed solution lies in the concept of Hawking radiation, the faint energy emitted by black holes as they slowly evaporate. Some scientists suggest that this radiation might carry encoded information about what fell into the black hole, preserving it in some form. However, this idea is still hotly debated, and the paradox remains unresolved. The implications of this paradox extend far beyond black holes. If information is indeed lost, it would force us to rewrite the laws of physics as we know them. It also ties into the holographic principle, the idea that all the information in a volume of space can be encoded on its boundary like a cosmic hologram. Could black holes be the key to understanding this mysterious connection between information, space-time, and reality itself? This theory challenges us to rethink our most basic assumptions about the universe. Are black holes cosmic vaults that lock away information forever, or are they gateways to a deeper understanding of the cosmos? As we explore the black hole information paradox, we're reminded once again that the universe is full of secrets waiting to be uncovered, and that even its darkest corners hold clues to the nature of existence. As we venture deeper into the mysteries of the cosmos, let's shift our focus to an idea that blurs the line between the possible and the absurd, the Boltzmann brain. This concept suggests that, given enough time, a self-aware entity could spontaneously form out of the chaotic dance of particles in the universe. It's a thought experiment that challenges our understanding of entropy, cosmology, and even the nature of consciousness itself. The Boltzmann brain is named after the physicist Ludwig Boltzmann, who proposed that the universe tends toward disorder, a state known as entropy. Yet, within this chaos, there's always a tiny chance that randomness could produce something highly ordered, like a fully functioning brain, complete with memories and thoughts. If the universe is infinite and eternal, as some theories suggest, it's not just possible but inevitable that such a brain could exist, floating alone in the void, convinced it's experiencing a real world. But why does this matter? For one, it raises profound questions about the nature of reality. If a Boltzmann brain could arise, how do we know we're not one? Are our experiences, memories, and sense of self just fleeting products of cosmic randomness? This idea forces us to confront the fragility of our understanding of existence and the universe. The theory also intersects with cosmology. If the universe continues to expand and entropy increases, the chances of such random formations become more plausible, even if they're astronomically low. Some scientists argue that the Boltzmann brain paradox undermines certain cosmological models, as it suggests they would predict more brains in the void than actual observers like us in a structured universe. At its core, the Boltzmann brain invites us to question the very nature of consciousness. Is it a product of careful biological evolution, or could it emerge from sheer chance in the vastness of space? While this idea may seem more like science fiction than science, it serves as a reminder of how strange and uncertain the cosmos can be, pushing the boundaries of our imagination and understanding. As we ponder the implications of the Boltzmann brain, we're reminded that the universe is not just a place of wonder but also of profound mystery, where even the most improbable ideas can spark the deepest questions about who we are and why we're here. Shifting our gaze to a new dimension of cosmic thought, let's explore the block universe theory. This mind-bending idea suggests that past, present, and future are not separate moments but exist simultaneously like frames in a film strip. Imagine time as a vast, unchanging block where every event that has ever happened or will happen is fixed in place, and our experience of time flowing is just an illusion. The block universe theory is deeply rooted in Einstein's theory of relativity, which shows that time is relative and intertwined with space in the fabric of the universe. According to relativity, what we perceive as now depends on our frame of reference. For instance, someone moving near the speed of light might experience time differently than someone standing still. This relativity of time supports the idea that all moments are equally real, just occupying different positions in the block. But how does this change our understanding of reality? If the past, present, and future coexist, it challenges our everyday notion of free will. Are our choices truly ours, or are they already written into the block? This theory doesn't deny the experience of time, but suggests that our sense of moving through it is a construct of our consciousness. The block universe also intersects with the concept of determinism, the idea that every event is caused by preceding events. If the future is already part of the block, it implies that the universe unfolds in a predetermined way. Yet, quantum mechanics introduces an element of unpredictability, leaving room for debate about whether the block is rigid or allows for multiple possibilities. This theory invites us to rethink the nature of existence itself. If time is an illusion, what does it mean to live in the present? Are memories and anticipations just parts of the same eternal block? While it may seem abstract, the block universe offers a profound perspective on the nature of reality, blending science and philosophy in a way that challenges our deepest assumptions about time and life. As we contemplate this timeless structure, we're reminded that the universe is far stranger than it appears, and even the fabric of time itself is woven with mysteries waiting to be unraveled. Now venturing into the realm of quantum mysteries, we encounter the observer effect, a phenomenon that blurs the line between observation and reality. At its core, this effect suggests that the act of observing a quantum system can fundamentally alter its behavior. Picture a particle, such as an electron, that exists in a state of superposition, meaning it can be in multiple states at once. When we attempt to measure or observe it, the particle collapses into a single definite state. This isn't just a quirk of measurement tools, it's a fundamental property of quantum mechanics. The observer effect raises profound questions about the nature of reality. If the act of observation can influence the behavior of particles, does this mean that consciousness plays a role in shaping the universe? Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that reality only becomes concrete when observed. This idea implies a deep interconnectedness between the observer and the observed, as if the universe responds to our awareness. But how far does this connection extend? Experiments such as the famous double-slit experiment demonstrate that particles behave differently when observed compared to when they are left unobserved. This leads to the tantalizing possibility that reality itself might be a collaborative creation between the universe and the mind. However, not all scientists agree on this interpretation. Some argue that the observer effect doesn't require consciousness, but rather that any interaction, even with a measuring device, can cause the collapse of the quantum state. This theory also intersects with broader philosophical questions about the nature of existence. If our observations shape reality, does this mean that multiple realities could exist based on different observers? Or is there a single, objective reality that we merely perceive in limited ways? The observer effect doesn't provide definitive answers, but it invites us to consider the possibility that the universe is far more dynamic and participatory than we once thought. As we reflect on this idea, we're reminded that the boundaries between the observer and the observed are not as clear-cut as they seem. the universe, it appears, is not just something we watch from the outside. It's something we actively shape through our presence and perception. This interconnectedness challenges us to rethink our place in the cosmos and the very nature of reality itself. With this thought in mind, let's continue our journey into the next theory, where we'll explore how this interplay between observation and reality might extend even further. Shifting our focus to the delicate balance of the cosmos, we now turn to the fine-tuning problem, a theory that probes the precision of the universe's fundamental constants. Imagine the laws of physics as a set of dials, each controlling a specific aspect of reality: gravity, electromagnetism, the strength of nuclear forces, and more. Even the tiniest adjustment to any of these dials could render the universe uninhabitable. For example, if the force of gravity was slightly stronger, stars would burn out too quickly, leaving no time for life to evolve. If it were weaker, stars might not form at all. This precise calibration has led scientists to ask a profound question: why is the universe so finely tuned to support life? One explanation is the Holographic Principle, which suggests that the universe must have the properties it does because we are here to observe it. In other words, if the constants weren't just right, we wouldn't exist to ponder them. This principle doesn't necessarily explain the fine-tuning itself, but frames it in a way that highlights our existence as a product of these conditions. Another intriguing possibility is the Multiverse Hypothesis. If our universe is just one of countless others, each with its own set of physical constants, then the fine-tuning of our universe might simply be a matter of probability. In this vast cosmic landscape, it's statistically likely that at least one universe would have the right conditions for life, and we happen to be in that one. This idea connects the fine-tuning problem to the broader concept of a multiverse, where an infinite number of realities exist alongside our own. Critics of the fine-tuning problem argue that it may be a result of our limited perspective. We only see the universe that allows us to exist, so it's impossible to compare it to other hypothetical universes with different constants. Additionally, some scientists suggest that future discoveries might reveal deeper laws of physics that explain why the constants are what they are, eliminating the need for fine-tuning as a concept. Despite the debates, the fine-tuning problem remains a fascinating lens through which to view the universe. It challenges us to consider whether our existence is the result of chance, necessity, or something beyond our current understanding. As we ponder this mystery, we're reminded of the intricate and delicate nature of the cosmos, a place where even the smallest details seem to align in ways that make life possible. With this thought in mind, let's continue our exploration of the universe's hidden connections, where the interplay of forces, constants, and probabilities reveals even more layers of cosmic wonder. Now turning to a theory that stretches the boundaries of our imagination, we explore the many worlds interpretation. This idea suggests that every quantum event doesn't just have one outcome, it spawns an entirely new universe. Picture this: every decision, every random quantum fluctuation creates a branching path leading to an infinite number of parallel realities. In one universe, you might have chosen a different career. In another, a cosmic event might have unfolded in a completely unexpected way. At its core, the many worlds interpretation challenges our understanding of reality itself. It implies that every possible outcome of every quantum event actually happens, but in separate, parallel universes. This means that somewhere out there, every version of you exists, living out every possible life path. It's a mind-bending concept that raises profound questions about identity. If an infinite number of yous exist across these universes, what does it mean to be you? This theory also has implications for the nature of existence. It suggests that the universe is not a single, linear timeline, but a vast, branching tree of possibilities. There's no single, correct path, just countless realities coexisting simultaneously. Some physicists argue that this interpretation neatly resolves certain paradoxes in quantum mechanics, like the famous Schrödinger's cat thought experiment, where a cat can be both alive and dead until observed. In the many worlds view, the cat is alive in one universe and dead in another, avoiding the paradox entirely. Critics, however, point out that the many worlds interpretation is difficult to test. Since these parallel universes are inaccessible, there's no way to prove their existence directly. Some also argue that the theory's infinite branching is overly complex, introducing more questions than it answers. Yet for many, the sheer audacity of the idea is captivating, offering a glimpse into a cosmos far more intricate and interconnected than we could have imagined. The many worlds interpretation invites us to rethink not just the universe but our place within it. It blurs the lines between possibility and reality, suggesting that every choice we make sends ripples across the fabric of existence. As we ponder this theory, we're left to wonder, if every path is taken, what does that mean for the nature of free will, destiny, and the stories we tell about ourselves? With this thought in mind, we move forward to another fascinating theory, where the universe's hidden connections continue to unfold in even more unexpected ways. Now shifting our focus to a paradox that has puzzled thinkers for decades, we delve into the grandfather paradox. Imagine this: you travel back in time and accidentally prevent your grandfather from meeting your grandmother. If that happens, you would never be born. But if you were never born, how could you have traveled back in time to alter events in the first place? This mind-bending scenario challenges our understanding of causality, the idea that every event is caused by a preceding one. The grandfather paradox forces us to question whether time travel could ever be possible without creating logical inconsistencies. If cause and effect are fundamental to how the universe operates, how can time travel exist without breaking this chain? Some scientists suggest that the paradox might be resolved by the concept of parallel universes. In this view, traveling back in time wouldn't alter your own timeline, but instead create a new branch in the multiverse. In this new reality, your actions might prevent your existence, but your original timeline remains untouched. This idea ties closely to the many worlds interpretation we discussed earlier. If every possible outcome exists in a separate universe, time travel might simply shift you to a different branch of reality rather than rewriting your own. However, this raises another question. If time travel creates new universes, does it truly allow us to change the past, or are we just moving into a new version of it? The paradox also invites us to reconsider the nature of time itself. Is time a fixed, unchangeable line, or is it more fluid, allowing for alternate paths and realities? Some theories propose that time isn't linear at all, but a complex web of interconnected moments. In this framework, the grandfather paradox might not be a paradox at all, but a reflection of our limited understanding of how time truly works. Critics argue that resolving the paradox with the multiverse theory introduces its own set of complications. For instance, if every action spawns a new universe, the implications for free will and personal responsibility become murky. Are we truly making choices, or are we simply following the path of one universe among an infinite number? Despite these challenges, the grandfather paradox remains a fascinating thought experiment. It pushes us to explore the boundaries of physics, philosophy, and our own understanding of reality. As we continue this journey through the universe's hidden connections, the paradox reminds us that even time, something we take for granted, is filled with mysteries waiting to be unraveled. With this in mind, we move into another intriguing theory, where the secrets of the cosmos continue to unfold in ways that challenge our perception of existence. Now turning to a theory that stretches the boundaries of our imagination, let's explore the idea that the universe itself might be conscious. This concept, often tied to panpsychism, suggests that consciousness isn't just a product of complex brains but a fundamental feature of the cosmos. In this view, even the smallest particles might possess some form of awareness, and the universe as a whole could be a vast, interconnected mind. panpsychism challenges the traditional notion that consciousness emerges only from biological systems. Instead, it proposes that awareness is woven into the fabric of reality itself. Imagine the universe not as a lifeless expanse but as a living, thinking entity. Could the stars, galaxies, and even the void between them possess a form of consciousness? This idea connects deeply with other theories we've discussed, such as quantum entanglement and the cosmic web. If particles can influence each other instantaneously across vast distances, it hints at a kind of universal interconnectedness that might underpin a cosmic consciousness. Similarly, the intricate structure of the cosmic web, with its filaments and nodes, could be seen as a kind of neural network on a universal scale. Critics argue that attributing consciousness to the universe raises more questions than it answers. How would such a consciousness function? Would it have intentions, thoughts, or desires? And if the universe is conscious, what does that mean for our place within it? Proponents, however, see this theory as a way to bridge the gap between science and spirituality. It offers a framework where the universe isn't just a collection of inert matter, but a dynamic, aware entity. This perspective also invites us to reconsider our relationship with the cosmos. If the universe is conscious, are we merely passive observers, or are we an integral part of its awareness? The theory also ties into the nature of existence itself. If consciousness is fundamental, it could imply that reality is, in some way, shaped by awareness. This idea echoes the observer effect in quantum mechanics, where the act of observation seems to influence the outcome of events. Could the universe's consciousness be actively shaping its own evolution? While the idea of a conscious universe remains speculative, it opens doors to profound questions about the nature of reality, awareness, and our place within the grand cosmic tapestry. As we continue to explore the universe's hidden connections, this theory reminds us that even the most fundamental aspects of existence might hold mysteries we've yet to uncover. With this in mind, we move forward to another fascinating theory, where the mysteries of the cosmos continue to unfold in ways that challenge our understanding of reality. Now shifting our gaze to the future of the cosmos, let's delve into the Big Crunch theory, a compelling idea that suggests the universe might not expand forever. Instead, it could one day reverse its expansion and collapse back into a single point, much like the singularity from which it began. This theory paints a picture of the universe's life cycle as a cosmic dance between expansion and contraction, creating a loop of creation and destruction. The Big Crunch is often seen as the mirror image of the Big Bang. Just as the universe burst into existence from an infinitely dense point, it could someday collapse back into that same state. This idea hinges on the balance between the force of gravity, which pulls matter together, and the energy driving the universe's expansion. If gravity eventually overpowers this expansion, the universe could begin to contract, pulling galaxies, stars, and even space-time itself back toward a single point. This theory connects deeply with our understanding of the Big Bang. In fact, it raises the possibility that the Big Bang might not have been a one-time event but part of an ongoing cycle. Some scientists speculate that the universe could undergo endless cycles of expansion and collapse, giving rise to a series of universes, each born from the remnants of the last. This cyclical model offers a fascinating alternative to the idea of a linear, one-way cosmic journey. However, the Big Crunch theory faces challenges in light of recent observations. The discovery that the universe's expansion is accelerating, driven by a mysterious force known as dark energy, has led many to question whether a collapse is even possible. If dark energy continues to dominate, the universe might expand forever, leading to a very different fate known as the heat death of the universe. Despite these uncertainties, the Big Crunch remains a thought-provoking concept that invites us to consider the universe's ultimate destiny. It challenges us to think beyond the present moment and imagine the cosmos not as a static entity but as a dynamic, ever-changing system. What would it mean for reality if the universe were destined to collapse? Would it mark the end of existence or the beginning of something entirely new? As we ponder these questions, the Big Crunch theory reminds us that the universe's story is far from complete. It's a story that continues to unfold, filled with mysteries waiting to be discovered. With this in mind, we turn to another captivating theory, where the hidden connections of the cosmos reveal yet another layer of its infinite complexity. Now shifting our focus to the quantum realm, let's explore the fascinating theory of the quantum multiverse. This idea suggests that quantum mechanics, the science of the very small, could be the key to unlocking the existence of countless parallel universes. Unlike the traditional multiverse theories that rely on cosmic inflation or higher dimensions, the quantum multiverse emerges directly from the strange and unpredictable behavior of particles at the quantum level. At the heart of this theory lies the concept of quantum superposition, where particles exist in multiple states simultaneously until they are observed. The many worlds interpretation proposed by physicist Hugh Everett takes this idea a step further. It suggests that every time a quantum event occurs, the universe splits into multiple branches, each representing a different outcome. In this view, every possible outcome of a quantum decision actually happens, but in separate, parallel universes. Imagine flipping a coin. In our universe, it lands on heads. But in another universe, it lands on tails. According to the many worlds interpretation, both outcomes are equally real, each unfolding in its own distinct universe. This means that for every decision, every random event, and every quantum interaction, a new universe is created, branching off from our own. The result is an infinite web of parallel realities, each slightly or drastically different from the next. The quantum multiverse challenges our understanding of reality itself. It raises profound questions about the nature of existence, identity, and free will. If every possible outcome occurs in some universe, does that mean our choices are predetermined, or do we still have agency in shaping our lives? And what does it mean for the concept of individuality if countless versions of us exist across these infinite worlds? This theory also connects to other multiverse ideas we've explored. For example, the quantum multiverse could coexist with the brain multiverse or the cosmic inflation multiverse, creating layers upon layers of parallel realities. It's a reminder that the universe or multiverse is far more complex and interconnected than we can fully comprehend. While the quantum multiverse remains a speculative idea, it's supported by the rigorous framework of quantum mechanics. It's a theory that pushes the boundaries of our imagination, inviting us to consider a reality where every possibility is realized. As we continue to explore the hidden connections of the cosmos, the quantum multiverse stands as a testament to the infinite mysteries waiting to be uncovered. With this mind-bending concept in view, we now move to another theory that delves into the ultimate fate of our universe and the role of entropy in shaping its destiny. Now turning to one of the most intriguing theories about the universe's ultimate fate, we delve into the concept of the heat death of the universe. This idea paints a picture of a cosmos that, over unimaginable stretches of time, will reach a state of maximum entropy where all usable energy has been evenly distributed and no more work can be done. It's a scenario that ties deeply into the laws of thermodynamics, particularly the second law, which states that entropy or disorder in a closed system always increases. To understand the heat death, imagine the universe as a vast cosmic clock winding down. Stars will eventually burn out, black holes will evaporate over trillions of years, and all matter will decay into its most basic forms. In this distant future, the universe will become a cold, dark, and nearly featureless expanse, with no sources of energy left to power stars, planets, or life. It's a stark contrast to the vibrant, dynamic cosmos we see today. This theory connects to the broader study of thermodynamics, which governs the flow of energy in the universe. Just as a cup of hot coffee cools to match the temperature of its surroundings, the universe is on a path toward thermal equilibrium, where all regions will share the same low temperature. At this point, no gradients or differences in energy will remain, and the universe will effectively run out of steam. The heat death also raises profound questions about the nature of existence and time. If the universe reaches a state of maximum entropy, could it ever reset? Some theories suggest that quantum fluctuations or other mechanisms might eventually spark a new cycle of creation, but this remains speculative. For now, the heat death stands as a powerful reminder of the finite nature of all things, even on a cosmic scale. This concept is deeply interconnected with other theories we've explored, such as the Big Crunch and the Big Bounce. While those ideas propose a cyclical universe, the heat death suggests a more linear and irreversible path. It's a humbling perspective that challenges us to consider the impermanence of the cosmos and our place within it. Though the heat death of the universe lies trillions of years in the future, it's a theory that invites us to reflect on the long-term destiny of everything we know. As we continue to uncover the hidden connections of the universe, this idea remains a cornerstone of our understanding of time, energy, and existence itself. Now turning to a theory that stretches the boundaries of our imagination, we explore the brain multiverse. This idea posits that our universe is just one of many brains, short for membranes, floating in a higher dimensional space. Imagine a loaf of bread where each slice represents a separate universe, existing parallel to our own within a larger, unseen dimension. The brain multiverse emerges from string theory, which suggests that the fundamental building blocks of the universe are not particles but tiny, vibrating strings. These strings exist in higher dimensions beyond the three of space and one of time that we experience. In this framework, brains are vast, multidimensional surfaces where these strings can attach and vibrate, giving rise to the physical properties of a universe. What makes this theory so fascinating is its implications for the nature of reality. If multiple brains exist, each could host its own universe with entirely different physical laws. Some might be teeming with life, while others could be barren or wildly chaotic. The collision or interaction between these brains could even explain cosmic events like the Big Bang, as if our universe was born from a ripple in the higher dimensional fabric of space. This concept also ties back to string theory's quest to unify all forces of nature. By envisioning our universe as a brain within a higher dimensional space, physicists hope to resolve long-standing questions about gravity, quantum mechanics, and the fundamental nature of reality. It's a bold step toward understanding the cosmos, blending mathematics, physics, and imagination. The brain multiverse invites us to consider the possibility of countless other universes, each with its own story, existing just beyond our perception. It's a reminder that the universe, or multiverse, may be far stranger and more interconnected than we ever imagined. As we continue to explore these hidden connections, theories like this challenge us to rethink the very fabric of existence and our place within it. Stepping into one of the most ambitious quests in science, we now explore the theory of everything. This concept represents the ultimate goal of physics, to unify all the fundamental forces and laws of nature into a single, comprehensive framework. Imagine a puzzle where every piece, gravity, electromagnetism, the strong and weak nuclear forces, fits together perfectly to reveal the complete picture of how the universe works. The theory of everything seeks to bridge the gap between two of the most successful but seemingly incompatible theories in physics: general relativity, which describes the behavior of massive objects and the fabric of space-time, and quantum mechanics, which governs the behavior of particles at the smallest scales. While general relativity excels at explaining the cosmos on a large scale, quantum mechanics provides insights into the subatomic world. Yet, when these two meet, such as in the extreme conditions of a black hole or the early moments of the Big Bang, their contradictions become glaring. String theory has emerged as one of the leading candidates for this unifying framework. By proposing that the fundamental building blocks of the universe are not particles but tiny, vibrating strings, it attempts to reconcile quantum mechanics and relativity. These strings, existing in higher dimensions, could account for all known particles and forces, weaving them into a single tapestry. However, the journey toward a theory of everything is fraught with challenges. The mathematics involved is extraordinarily complex, and experimental evidence to validate these ideas remains elusive. Physicists are also exploring other approaches, such as loop quantum gravity, which seeks to quantize space-time itself, and M-theory, an extension of string theory that posits the existence of multiple dimensions and brain. What's remarkable about this pursuit is its potential to answer some of the deepest questions about the universe. Why do the fundamental constants have the precise values they do? What is the true nature of space and time? Could there be a single equation that explains everything from the motion of galaxies to the interactions of quarks? The theory of everything isn't just a scientific endeavor, it's a philosophical one. It challenges us to rethink our understanding of reality, pushing the boundaries of human knowledge. While we may not yet have the answers, the quest itself inspires us to keep exploring, to keep asking questions, and to keep uncovering the hidden connections that bind the cosmos together. Now turning to one of the most profound echoes of the universe's birth, we delve into the cosmic microwave background. This faint radiation, often referred to as the afterglow of the Big Bang, is the oldest light we can observe, dating back to when the universe was just 380,000 years old. It's like a cosmic snapshot capturing the universe in its infancy, and it holds invaluable clues about its origins and evolution. The discovery of the cosmic microwave background in the 1960s was a monumental breakthrough. It provided the first direct evidence for the Big Bang theory, confirming that the universe began as an incredibly hot, dense state and has been expanding ever since. This radiation isn't just a uniform glow, it contains tiny fluctuations in temperature, which are like the seeds of structure in the universe. These fluctuations eventually grew into the galaxies, stars, and cosmic web we see today. Understanding the cosmic microwave background has allowed cosmologists to piece together the early history of the universe with remarkable precision. By studying its patterns, scientists have determined the universe's age, composition, and even the rate of its expansion. It's a cornerstone of modern cosmology, offering insights into dark matter, dark energy, and the fundamental forces that shaped our existence. But why does this matter? The cosmic microwave background isn't just a relic of the past, it's a window into the very fabric of reality. It challenges us to ask how the universe began, why it looks the way it does, and what its ultimate fate might be. It reminds us that every star, every galaxy, and every atom in our bodies is connected to this ancient light, a bridge between the beginning of time and the present moment. As we explore this cosmic fingerprint, we're not just uncovering the secrets of the universe's origins, we're also illuminating the path toward a deeper understanding of reality itself. The cosmic microwave background is a testament to the power of science to reveal the hidden connections that bind the cosmos together, guiding us ever closer to the answers we seek. Now shifting our gaze to a theory that blurs the line between the cosmos and life itself, we explore the Gaian universe. This intriguing idea suggests that the universe isn't just a random collection of stars and galaxies, but a system that evolves in ways that support the emergence and sustenance of life. It's as if the cosmos has a built-in tendency to nurture life, making it a participant in the grand story of existence rather than a mere backdrop. The Gaian universe theory takes its inspiration from the Gaia hypothesis, which proposes that Earth functions as a self-regulating system to maintain conditions suitable for life. Extending this concept to the entire universe, the theory posits that cosmic processes may also be fine-tuned to favor life's existence. This aligns closely with the Holographic Principle, which argues that the universe's fundamental constants and laws appear perfectly calibrated to allow life to arise. But what does this mean for our understanding of existence? If the universe is inherently life-supporting, it challenges the notion that life is a rare accident in an indifferent cosmos. Instead, it suggests that life might be an integral part of the universe's evolution, a feature rather than a fluke. This perspective shifts our view of the cosmos from a cold, mechanical system to one that is dynamic, interconnected, and perhaps even purposeful. The implications of the Gaian universe theory stretch beyond science into philosophy and even spirituality. It invites us to reconsider our place in the cosmos, not as isolated beings, but as expressions of a universe that seems to favor our existence. It raises profound questions about the nature of reality, the origins of consciousness, and the ultimate purpose of the cosmos. As we reflect on this theory, we're reminded of the intricate balance that sustains life on Earth and the possibility that this balance extends to the universe at large. The Gaian universe theory encourages us to see the cosmos not as a distant, unfeeling expanse, but as a living, evolving entity that holds the potential for life in every strand of its fabric. It's a perspective that deepens our connection to the universe and inspires us to explore its mysteries with newfound wonder. Now turning to a concept that flips our understanding of cosmic phenomena on its head, we delve into the white hole hypothesis. While black holes are known for their immense gravitational pull, from which not even light can escape, white holes are theorized to be their exact opposites, regions of space where matter and energy can only pour out, never to return. Imagine a black hole in reverse, a cosmic fountain spewing light and matter into the universe rather than consuming it. The idea of white holes arises from solutions to Einstein's equations of general relativity, the same framework that predicts black holes. These equations suggest that, mathematically, white holes are just as valid as black holes, even though we've never observed one. In fact, some theorists propose that a white hole could be the other end of a black hole, connected by a theoretical tunnel called a wormhole. This raises the tantalizing possibility that matter swallowed by a black hole could re-emerge elsewhere in the universe through a white hole. But what would a white hole look like and how might it behave? Unlike black holes, which are shrouded in darkness, white holes would be incredibly bright, emitting vast amounts of energy and matter. Yet, their very nature makes them unstable and short-lived, which could explain why we haven't detected them yet. Some scientists speculate that certain cosmic explosions, like gamma-ray bursts, could be signs of white holes, but this remains a topic of debate. The implications of white holes extend far beyond their theoretical existence. If they are real, they could reshape our understanding of space-time, offering clues about the origins of the universe or even the possibility of alternate universes. They might also help us reconcile the paradoxes of black holes, such as the information loss problem, by providing an exit for the matter and energy that seems to vanish into them. While the white hole hypothesis remains speculative, it invites us to stretch the boundaries of our cosmic imagination. It challenges us to consider that the universe might be far stranger and more interconnected than we ever imagined, with phenomena that defy our everyday understanding of reality. As we explore this theory, we're reminded that the cosmos still holds countless mysteries waiting to be uncovered, each one offering a new perspective on the nature of existence itself. Now shifting our focus to one of the most profound and mind-bending ideas in cosmology, we explore the theory of the end of time. What if time, the very fabric of our existence, were to simply cease? This concept challenges everything we know about the universe, suggesting that time might not be an eternal, unchanging force but something with a beginning and potentially an end. The idea of time ending originates from theories in physics that examine the ultimate fate of the universe. Some models predict that as the universe expands and approaches maximum entropy, time could lose its meaning. In a state of cosmic equilibrium where all energy is evenly distributed and no further change occurs, time might become irrelevant. This would mean that past, present, and future would no longer have any distinction, aligning with the block universe theory, which posits that all moments in time exist simultaneously. But how could time end, and what would that look like? Imagine a universe where every process grinds to a halt, where stars stop burning, particles cease to move, and even the ticking of clocks becomes meaningless. In such a scenario, the concept of now would dissolve, leaving a static, timeless state. This idea is not just speculative. It emerges from the laws of thermodynamics and our understanding of entropy, which suggest that the universe is heading toward a state of maximum disorder. The implications of the end of time are staggering. It raises questions about the nature of reality, the flow of existence, and even our perception of life. If time were to end, would consciousness persist in some form, or would it simply fade away? These questions blur the lines between physics and philosophy, inviting us to rethink our place in the cosmos. Moreover, this theory connects deeply with the block universe concept, which suggests that time is an illusion, and all events are equally real and unchanging. If time were to end, it would reinforce the idea that what we perceive as a linear progression is merely a construct of our minds, masking a deeper, timeless reality. As we ponder the end of time, we are reminded once again of the universe's strangeness and the limits of our understanding. It challenges us to consider that reality might be far more intricate and mysterious than we can ever comprehend, pushing the boundaries of both science and imagination. With this thought, we leave you to reflect on the profound implications of a timeless universe and what it means for the ultimate fate of existence itself. As we reach the end of our exploration, let's take a moment to reflect on the 30 theories we've uncovered about the universe's hidden connections. From the holographic principle to the end of time, each idea has revealed a unique perspective on the intricate web that ties everything together. These theories, though diverse, share a common thread. They challenge our understanding of reality and invite us to see the cosmos as a deeply interconnected, ever-mysterious entity. Whether it's the cosmic web binding galaxies, the quantum entanglement linking particles across vast distances, or the possibility of a multiverse teeming with alternate realities, these concepts push the boundaries of science and imagination. They remind us that the universe is far more complex and enigmatic than we can fully grasp. And while each theory offers a piece of the puzzle, they also leave us with more questions than answers, fueling our curiosity and driving us to explore further. We encourage you to take a moment to ponder these ideas. What do they mean for our place in the universe? How do they reshape your understanding of existence? Share your thoughts in the comments below. We'd love to hear your insights and theories. If you've enjoyed this journey through the cosmos, make sure to subscribe and hit the notification bell so you don't miss our future explorations into the mysteries of the universe. There's so much more to discover, and we can't wait to continue this adventure with you. Until next time, keep looking up and wondering, because the universe's secrets are waiting to be unraveled.